Hello. Today we want to look at the energy in a spring. You have done some experiments with a spring and you've put masses on that spring, and that spring got longer and longer as you put masses on there. And we were wondering, how can we tell how much energy is stored in that spring? So I want to look at this graph because this graph actually gives us an idea how much energy would be stored in that spring, right? So you guys can think here, let's say we put masses on that spring and we stretched that spring until it was a length of zero point 0.5 meters, okay? How much energy would be in that spring? Well, you would know that there would be um, there would be a small amount of energy in that spring, and we could maybe draw that small amount of energy by just drawing a circle that looks like this. There's our pie chart, and we would write energy, and it would be elastic energy in that spring, so I'll write EL. Okay, so we got elastic energy in that spring. Now, imagine we actually went ahead and we stretched that spring until it was all the way 1 meter long. Well, you can imagine that it's harder to pull a spring when you've already pulled it a certain distance. All right, so it's a lot harder to pull that now. So our pie would be getting bigger. Okay, it took only this much energy to pull it to half a meter, but now to pull it a full meter, it's going to take us a lot more energy. And so I'm drawing another pie. Okay, and you can see that's more energy now. Okay, and you can imagine too that if we expand and we pull our spring even farther, it's harder and harder to pull. And so now, if I were to draw a pie for that, it would be storing a lot of energy. And so I'm going to draw an even bigger pie. Whoops. I'm going to draw an even bigger pie in here. All right. And so our pie gets bigger the more we stretch it. Okay. Now, if you think about this, guys, there were two variables that determined how much energy in our spring. Well, maybe three. Let's talk about those. All right. We had the length. It's how long we pull it. We also had the force pulling down. Now, the force was two variables. Really, it was the mass of the object and how hard gravity was pulling down. Okay. Or we could think of force if my arm was pulling the string down, then it would just be the force from my arm, one thing. Okay. And so those two variables, it turns out that if we want to figure out how much energy is in a spring, we need to think about length. We need to think about the force. And so I'm going to write an equation right here on the board. Energy in a spring equals the force times the length. Now, there's one other problem, one other thing that goes with that, and I'm going to put a 1/2 in front of here. Because it turns out the energy in the spring is the amount of area under this graph. Right where that pi is, that tells us how much the energy in the spring is. So I'm going to just shade this in, okay? And how do I find out how big this area is? Well, that's a triangle. And you know that the area formula for a triangle is base times height divided by 2, or times 1/2, okay? So the energy in the spring equals the height right here, which is the force, okay? And then it's the length right here, right there. And then we have to divide by 2 because to get the area of a triangle, we have to divide by 2, okay? And that's why the energy in a spring is 1/2 force times the length of that spring. Write down that equation and save it.